So that's the second talk about WASM for today, and I hope it will add some value to the whole thing. But I will start with some story. I don't know. I've seen things you people wouldn't believe. Node.js running in browsers powered by WebAssembly. I watched bug reproductions, quick experiments, live documentation examples, all those moments available for JavaScript, but missing for Ruby, like tears and rain. But it's not time to die, it's time to change. So welcome to Assembling the Future. I'm Svyatoslav Kryukov, a developer at Evil Martians, and we are going to piece together a future where Ruby shines bright in neon lights. But our story starts with StackBlitz. It's a fully working in-browser IDE, and the most fascinating part about it, it runs Node.js right in the browser using WebAssembly. I'm a big fan of StackBlitz, but it doesn't support Ruby. So when I saw that Yuta Saito was working on Ruby.wasm, I thought, why should JavaScript developers have all the fun, right? That's when I decided to create this mini StackBlitz for Ruby. And I created runruby.dev. It's a Ruby playground, like many others, but with a twist. It's also an emulated development environment. This means we have virtual file system, ability to install gems from your gem file, and limited network support as well. And all of that runs in your browser. Today I want to show you what it takes to build such thing. We'll start with some mandatory info about WASM, and yeah, honestly, I'm still learning it, and the technology is so young and actively developed, it might change while we're speaking. Yeah, and next we'll take a look at Ruby.wasm and discuss how to overcome its current limitations. And by the way, Yuta, I see you working on something. Please don't push anything. He's so fast, I'm afraid this talk will be stale while we're talking. Yeah, and we will show how to overcome some of current limitations of Ruby.wasm. And let's start with WebAssembly. To be honest, WebAssembly is a complex beast. And for today's talk, we only need two things to know. It's a binary instruction format, and it is designed to be a sandbox. Let's break it down. So the binary instruction format means portability. WASM acts as just another target for your LLVM toolkit. So we can compile your code, or say Ruby interpreter, for example, into WASM module alongside other platforms. That will make it executable on different WASM runtimes, like the official WASM time, feature-rich WASMer, and many more, including all browsers, because they all can execute WASM modules. This is an example of a simple WASM module, and you can see on the right, I hope you can see it, that it imports and exports some functions. And this is the sandbox part I'm talking about. You can't do anything outside of the module unless you explicitly exported and imported stuff. So for instance, even to print hello world, we must import a function because it's I/O. And for the browser, it means we need to write quite some JavaScript, right? In the basic setup, we only need to initialize the module and call the exported function. But due to this low-level nature of WebAssembly, we also need to work with some pointers, and this is pretty ugly, if you ask me. And there is obviously must be a better way to work with WebAssembly. And of course there is one. It's WASI, WebAssembly System Interface. It defines a list of standard syscalls like POSIX, and it enables WebAssembly modules to run on different platforms. WASI releases new APIs in numbered previews, and this is how it looks like. Basically, this is the WASI interface description. And the list of defined functions is quite limited. So for example, with WASI Preview 1, we can't use threads, networking, and much more. And all that obviously affects Ruby.wasm as well. To make WASM work with WASI, on the module side, we need to inject WASI functions instead of syscalls. And this is done via WASI SDK. On the host side, there are two options. We either have an implementation of WASI functions, the WASI interface, or we need to use shims. And in case of browser, there are shims to use. Here's an example of a shims function that we saw earlier. That's, you don't want to write that every day, right? Shims provide a list of ready-to-use WASI functions to import into the WASM module, and POSIX-like entities like virtual file system and so on to use on the JavaScript side. So we have this connection. Actually, Ruby.wasm can be initialized with a new, more powerful WASI Preview 2 already, thanks to Euruko, which can unlock networking, for example. But full support is not yet ready on either WASI SDK side and also on shims side. Hope Euruko will fix that for us. But for now, we need to use WASI Preview 1. Now let's talk about Ruby.wasm. What it is exactly, right? It's C Ruby interpreter with a set of patches to remove or implement some parts of like core library, and with injected WASI functions. Since it uses WASI, it shares the same problems. No threads, no networking, no dynamic linking. And here is, okay, you can't do that, I guess. But there is a link to the talk from Euruko. Although dynamic linking is kind of reduces the number of gems we can use, we still can use a lot of gems in WASM. And there are two ways we can install gems. So at build time, via a special packaging system, we can also unlock some of the C extensions. And I think you saw the talk by Euruko. He explained that. And the second option is to do that in runtime. And that's what we're going to do today. And to do that, we need to use networking. But how to do that without networking? Here we can use a special feature of Ruby.wasm, JavaScript interop. That's one of the most exciting things with Ruby.wasm, and it's easier to show than explain. With JavaScript interop, we can execute Ruby code from JavaScript and pass values back, so both Ruby and JavaScript are interlinked. With that knowledge, we can finally proceed to Ruby Playground implementation. First of all, we will need to run Ruby in browser. Then we want to share file system to use it in Ruby and also to show that in the browser and edit files and so on. Big chunk of work will be also related to enabling bundler. And finally, we will also, as a bonus, spin up a server with Ruby on board. So first, let's see how to run Ruby in browser. This is a simple script from the README. We only need to import this browser script that does the whole magic, and we can execute Ruby code in a special script tag. This allows us to run Ruby script once, which is, we couldn't make our thing work with that. So let's enhance this example. By exposing this default Ruby.wasm function, we can now access the Ruby virtual machine and also replace versions of Ruby.wasm file itself. So you can pre-build something and use it. It's great, but let's zoom into this default Ruby.wasm function as well. Yeah. Finally, we can see familiar WASI glue code, the file system, the imports, everything is here. And here is also like some Ruby.wasm initialization as well. We don't need to care about that. Now, when we know where to find WASI code, like in the whole file system initialization, let's focus on sharing the file system part. Here's a basic example. Here we create a Ruby file and put it into the directory. Once the file system is set up, we can run files from Ruby. To make example more dynamic and interactive, we will use code mirror to modify files and also add a button to execute theme and display the result. So demo time. Yeah, CSS is hard, so it looks not really nice. But yeah, it works. And also, I think it's dynamic. Okay, I missed. But you see, errors are also live. So, thanks to WASI, the file system is just an in-memory JavaScript. So we can use it on JavaScript side to manipulate it and also to read that as a real file system on the Ruby side. With that out of the way, let's focus on installing gems via bundler. This is a simple script behind the bundle install command, and let's try to run it in our editor. Why not? Okay, error. That's why you don't do live coding, right? In this case, error comes from a missing core class socket. To handle this kind of problem, we can just re-implement missing class just enough to avoid the error. And sometimes it means that we can just create an empty file. Sometimes we need to implement some methods. For our case, this is enough. Then we can create this virtual directory and put those files there. And we also need to prepend the load pass global variable because Ruby uses that to find required files. Let's try it. Okay, another error. So this time it's directly related to the missing cruby function. Sorry? Oh no! Jesus! Okay, I will click it on here. Sorry. Not you, you. Oh! Okay, I will do that like that. Thank you. So, yeah. We have an error. Where is my mouse? Sorry, that will be ugly. This is related to the missing serial Ruby functions, and when this happens, it means that we use syscall that is not available in WASI. So keep kids away from the slides because we are going to monkey patching. This is just an example. There are a lot of monkey patches in my version of code. And yes, it's ugly, but this is how it works right now, right? Hello, mouse. Let's go here and click on it. Ooh. Okay, another error. So sometimes you must stop blindly patching everything and find the right spot to apply your patch, because in this case we're already trying to access network and there is no reason to re-implement OpenSSL. That wouldn't work. So in this case it's time to finally play our JavaScript interop card. In this method we are going to use JavaScript's fetch and parse it and return to Ruby as a Ruby object. And after that, yes, again, monkey patching. That's how it works right now, sorry. Hello? And it works. This is not a fly in Ruby that you saw, but yeah, it's fine, I guess. The gem just been downloaded and installed, and the code is running. Cool. Finally, it's important to be creative when you are working with the current state of Ruby.wasm, because here is a list of minor issues I also was forced to kind of fix. Course issues, for example, Ruby gems don't allow you to download gems, so I need to implement proxy. Also, when you call bundler install first time, it tries to cache all the metadata, like all the versions, all that, and yeah, it's slow. And you saw this is fine even on this Wi-Fi, so I just re-implemented the whole thing in the cloud and just download one file instead of like many. And yeah, there is something else always, you know. Now something special, the feature that doesn't exist in run ruby.dev, and if you want you can come to me after the talk and I will tell you why. So let's enable web server with Ruby.wasm. This is our Sinatra application, nothing special, just a couple, you know, roads. And the thing is that we have this Rake thing in Ruby world, which makes it really easy to replace, say, Puma with a JavaScript code. Same thing with fetches, almost, like we're trying to serialize data from JavaScript back to Ruby. And then in Ruby we use mock request on the Ruby, yeah, and just call Rake application like that. The question is, like this is already, I know, kind of obvious. So the question is where to put this code. And there are several options there. We can use service worker. Another option is WebRTC. It's a bit hacky, and I don't know, I never tried it, but it looks promising. And the final version, like we can use some custom networking layer, like one done in StackBlitz web containers. But today, service worker will be fine for us. I think we need to can explain what service worker is, and it's a script that is running in parallel with your web page, totally separated. So this snippet interrupts all the requests and provides a custom response from Ruby instead of like version requests that could go. Okay, we have this demo. Let's see if it works. Yeah, it works. Cool. So again, this is not a Rails application that Yuta showed, but it's fine. And yeah, obviously, there is a small difference between this demo and the demo that Yuta showed, because all the things that I showed are working without pre-built version of Ruby. This is the thing. And to run Rails, we need to overcome a lot of problems. Like there is no way right now to use WASM gems with C extensions. There is problem with database adapter because it uses sockets, so we need again to rewrite some things, and there are much more like problems. But the whole toolkit of patching everything and everywhere keeps the same. So yeah, we can run Rails actually. And you know, today in this talk, we did a lot of horrible things. We implemented and like patched some core classes really poorly. We wrote some JavaScript, which is a sin for someone, like, I don't know. But despite all those problems and hacks and limitations, I'm really thankful that Ruby already allows us to, glimpse into the future and try WebAssembly that I think will replace everything. And there will be a world with a perfect uniform, platform unification, But for now, that's it. Thank you.